So, Kyle.
Thank you, Laura. So, thank you, everyone. Welcome to Thinking Capital. So, I'm very happy to have you here tonight. And first of all, I have to thank all of our Talend D, Laura and Drew, for organizing this evening, and our Talend T people from Thinking Capital for organizing all of this. I think it's great, great evening and a very nice organization. So a little round of applause, please, for everyone. So I'm going to start out the evening with just presenting what Thinking Capital does and what I do at Thinking Capital. So I'm a data architect at Thinking Capital. I've joined about a year ago now. And Thinking Capital is a company that finances and funds small and medium businesses throughout Canada. And we are the leading company in that area. So this is a bit what we do. Now I'm going to present to you because how we work with Salesforce. The whole company was built upon Salesforce and grew with Salesforce throughout the last at least 10 years. And we went through a lot of changes, through a lot of transformations. So I want to give back a bit of our experience on how we work with Salesforce and how we integrated Salesforce with different enterprise level systems. Okay, so this is the agenda of my talk. So Salesforce, why Salesforce, and what is Salesforce? What Thinking Capital did with Salesforce, and where Thinking Capital is going with Salesforce. And then within the direction where we're going with Salesforce, we had to build very strong or set very strong enterprise architecture orientations. So I'm going to present the guidelines through which we implement our integrations. Throughout all of that, I'm going to present to you a bunch of constraints in which we have to navigate through to build all of our systems and integrate all of our systems. So the first part of the talk are the different patterns that I'm going to present that we tried out, we failed, we succeeded, is from Salesforce to TC, and then from Thinking Capital back to Salesforce. This is the two flows for bidirectional integrations. And then, well, during my presentation, please ask me questions if you have any. Okay. So Salesforce. Salesforce, first of all, it's a customer relationship management system. It can do a lot of things. And Wikipedia tells us that it's an interface where we can manage cases, tasks for sales, services. It offers us a bunch of features such as a customer portal, reporting tools, analytics, emails, marketing, all kinds of things. And among all that, as well, manage our customer information. And it can do actually more and much more than all of these things. It's a full development platform. We can do a lot of things with this. And actually, Thinking Capital did a lot of things with this. We grew by over 40%, 50% per year over the last 10, 12 years. So you can do a bunch of things. But what you cannot do, and you shouldn't be doing, and you shouldn't even thinking about, is doing HR within the system. You shouldn't be doing any kind of recruitment, managing, let's say, emailing. It's not an ERP system, it's not an accounting system, it's not a lending system. You shouldn't be storing all of your videos, your pictures, and everything on Salesforce. You can do it. It works. It works very great. I think I have to migrate about half a terabyte of files. I don't know what they are. So you cannot do all of that. I'm sure if there was a script out there, I can even make coffee with it. I can call it a coffee machine, hack it through, and get coffee done. So you shouldn't be doing all of this. We did some of these. We learned from this, and now we're getting out from here. But how are we supposed to integrate Salesforce in a more enterprise way and with enterprise systems? So this is the question. How are we doing these bi-directional integrations between enterprise level systems, a real ERP system, a real, let's say, MDM system, a real accounting system, and so on? So this is the, what I'm going to present to you. So we went through all of these transformations, and then we set a bunch of enterprise architecture guidelines and orientations. We wanted to integrate all of these systems through an API-oriented architecture. We want dedicated systems for each business process and each business function. Accounting has to have its own system. It might need some custom information. It might come from Salesforce. We're going to integrate it properly. So we have different systems of record for different data domains, customers, accounting, documents, anything that you can think of. So, for example, for customer domain, since we are multi-channel, multi-tenant system, we use Talend MDM platform to manage customer data, to manage reference data, to manage a bunch of other domains. We built a whole infrastructure and architecture where we separate data, we separate transactional data, we separate operational data from analytics and so on. And each layer has its own and proper integration mechanisms that are set at an enterprise level. So for example, any kind of real-time integration, we go through an API platform that manages all of these APIs. For anything that is near real-time or batch, we have a dedicated system to do so. So that is the general architecture. Now when we dive in and look into the integrations, one of the main things that we want to do is, as soon as you generate a piece of information, we want that information to be available to any other systems that has any kind of interest. If you're generating a new address for a customer, we want it to flow everywhere. So a scenario that happens, the person is on the phone with one of our sales rep, he's updating some phone number and address. He's going to go onto his phone or on the portal to check that that information has been updated. We want that information to flow as seamlessly as possible to that all of the systems that need information. Okay? So we want to publish new or updated data as soon as possible. We are integrating in near real time with our systems using a publish and subscribe mechanism implemented on the Talend different components. And to do so, we've defined an enterprise canonical data model to have a uniform messaging format throughout all of the systems. And one very strong assumption is that if you need data, you want it, okay, we're going to give it to you, but you're responsible to actually consume the data. We want every system to be responsible and understand what data they're receiving and to process that data and make sure that they apply their own business rules on how to consume the data. Okay. So those are our guidelines. There are a lot of them. We've got a lot of constraints as well. So I'm sure everyone here is involved in the projects of some kind with time constraint, budget, skill set, and then you have the people, the infrastructure, the security people that tell you you cannot do that, you do not integrate that way, or you have to do it this certain way. You have a certain number of tools already implemented in your companies or organizations. You're using legacy systems and they have a bunch of limitations. So you have to you have guidelines, but you have all kinds of hurdles in front of you to actually get to what you want to do. So maybe at some point you have to choose. You might have a very good idea on how to integrate things, but in the end, it's not the first solution that you're going to implement, maybe the 4th, 5th, or 6th version. Okay. Okay. Any questions so far, everyone? Good. So first thing I'm going to present is how do we bring data out of Salesforce? How do we make any phone call, any customer information update available on the CRM into all of the other systems in the backend? Okay. The first way, very simple, very synchronous way of integrating is, you're in Salesforce, you're saving something, and as you press on a button, you're calling a service somewhere that actually writes the data in the system. So here in the pattern, you'll be on the UI, interacting with the UI, you save, and in the back, on the red flow, something is going to call an API. It can be a custom API, it can be a native API. So let's say that at Thinking Capital, we have an API platform, we are exposing a certain number of REST endpoints, so your code in Salesforce can just call that endpoint. And sometimes you're not happy with that. I don't know why. There are many reasons why, you know what, we want to keep these calls to originate from Salesforce itself. Okay, that's fine. You can create your custom service in Salesforce, go through that service to actually send data over the enterprise systems. Okay. Any questions? Very straightforward. Now, this is very synchronous. So you're really dependent on the fact that the APIs you're calling are up and running. And if they are not, well, you're going to be timing out and you're going to be losing data at some point. You might be losing some data at some point. So another idea is to go into this. Salesforce has great features to send data outside of Salesforce world. I'll get to this point later. They came up with this streaming API, so you configure these queries in SQL in Salesforce, and these works as just like triggers. You program these queries, and as soon as an action has happened on an object, so let's say you've created an account, you've updated an account, the query triggers and sends out a message into a channel or a form of queue. So here you get this little radar that's detecting all of these changes. As soon as this occurs, sends out the message into the channel. And now Salesforce is taking the nice side of the integration pattern. It's telling you, yes?
Excuse me, are you referring to a REST API?
It's a streaming API. So in Salesforce, this is a query you can build on top of objects. And as soon as you do an action on the object, it's going to trigger the query. The query is going to fetch the data that changed or was inserted, and it's going to put it into a channel. And now it's like MQ. It's like an MQ queue. It's up to you to come in and fetch the data. It's just like Salesforce is delivering the mail in the mailbox. Now you have to come and get it out. So this is the second integration pattern. The limitation of this thing is that the data that comes out is in Salesforce format. It's in Salesforce semantics and vocabulary. And it is Salesforce's objects that's been sent out. So for us at TC, we had one very strong orientation, is that we want to exchange data in between systems using our own model. So that means that if we went through this pattern, we would need to pick up the data in Salesforce format, change it into our model, and send it out to our enterprise systems. Okay? Does it answer your question?
Yes, I mean,
No problem.
say streaming API.
It's called streaming API, yeah. Okay, so, but this works very well. You don't need to do any kind of API calls to Salesforce. It's just sending it out, making it available to you. You come in, you fetch it, and you bring it out. Okay? So this is an example of the what comes out. You define a query, define the fields that you're interested in, and then it just sends it out and on, for example, an account update. And it's going to tell you what updated and what are the IDs of the objects that got updated, when, and you go in and fetch the data and consume it. Okay? Now, that is when we're using the streaming API from Salesforce. But now what I want to do is have the data in my own format. I want it to be following our own standards and following our own schema. To do that, whenever there is a change on an object that I'm interested in, I can build a trigger, and that trigger can actually generate a message. So the message would be generated through some Apex code. It can be just a notification message saying, hey guys, there's a change in this object, here's the ID of the object. Come in, fetch the data. Or it can be, you know what, oh, I found a new change in Salesforce. So I'm going to generate the message. I'm going to query all of the objects in Salesforce that connect together and that respect my canonical model. Generate a JSON message. We choose to go with JSON and send it out. So this first pattern here is through triggers and an Apex code that basically notifies any TC systems that, hey, there's a change in Salesforce, come in and fetch the data if you want. Okay? This means that, this one is when we are creating the message within Salesforce. So the whole burden is in Salesforce to understand what is the enterprise model, fetch all of the data, plug it together, and send it out. So in step 4, when we're sending it out, think that we are in 2 separate clouds. You need to manage your security. You don't want to be exposing some ActiveMQ or some MQ series queues outside to the world. So you have to put a service in front of those queues and have the proper security to be able to integrate between the 2 systems. So you're sending out the whole payload to an API, and that API, for example, the only thing it has to do is turn around, validate the security, turn around, and put the message in a queue inside TC systems. So from this, we fetch data inside Salesforce, we prepare the messaging, and we communicate it out to the outside world. And on the other side of the spectrum, what we need to do is go and collect the message, process it, and then consume it properly within any system that actually needs that data. So far so good? So this is Salesforce generating the full payload. The next integration pattern is very similar. It's instead of Salesforce having to generate the payload, it's just generating a simple message. And this can be actually very compatible with a streaming API. So Salesforce is telling you, hey, there's a change, come in, fetch the data. So what we do, we receive that message, we go and fetch that message, we look at what object changed, and then we have to go into Salesforce and start extracting from Salesforce using their native APIs or REST APIs to get all of the data, build the message, and then send that message down into our systems. So the burden is on the data team side or DTL side or the thinking capital side to do that, and not on the Salesforce developer side. So now, both patterns are good. It just depends where you have more skills, more resources to develop. Oh, something I didn't mention. In this case, when we have to go into Salesforce and start fetching data, you have many APIs you can call, but you have a lot of limitations on those APIs. So you have a limited number of calls during the day. I think right now we are limited at about 1 million calls. And if you have to fetch data across multiple objects, query the objects and see if they already have a record, if the record already exists and it's the one you need. Then if not, you have to create it. So there's a lot of back and forth between your system and Salesforce APIs. So the more back and forth like that, the more API calls you have to do, the more latency you introduce into your integrations. So this is something you have to consider. I think it was last year they came out with a composite API or a composite request, which is a way for us to bunch up together up to 25 calls to Salesforce. So for example, you need to create an account, a contact, different information on the account. But first you need to check if the account exists. So that would be the first API call in your request. And then you link them together, one to the other, so that in one single call to Salesforce, you can actually achieve up to 25 calls and populate multiple objects at the same time. So it optimizes the number of calls you actually make on the APIs. Okay, that's what the composite API call is about. So far so good. Any questions? A bit more technical, a bit less technical? Fine? Okay. Now, let's say we know how to get data out of Salesforce. Now we have to get data into Salesforce. The easiest way to do this is through a Talend data integration job, where basically you fetch data from your database, you turn it around, and you call Salesforce API. And if you want to get data out from Salesforce, every now and then you poll the Salesforce objects through the APIs. You ask, are there any new objects or new records since the last time I came in? And then you extract the data. It works. We've done that. And the problem is you're in a polling mechanism. So in a world where Salesforce resources are limited, the more you poll, the more you consume your API calls, the closer you get your users to be locked out. But it still works. It's a good solution for certain things, but what we want to do is to fetch data as soon as it is available in the CRM and bring it out into enterprise systems. So these two objectives are very, they don't go well together. This can work in certain situations. Okay? Now, if we want to make this a little bit more intelligent, if we have some kind of change data capture mechanisms, we can switch from a polling mechanism to a on-demand, or whenever the data is available, we go and fetch it. So this kind of ties back to the streaming APIs. It's a good way as well to achieve this. We can implement it on Salesforce side. We detect it, we go in and we fetch the data. Okay. Now, we have another mechanism which is based on publish and subscribe. What we want to do is whenever we are generating data in our environments, we want to channel that into, let's say, a queue and process the queue as it's filling up. So whenever we're filling up the queue, we fetch the message, we read it, and we say, okay, this is data that I need to push into Salesforce. So I'm going to turn around, I'm going to call Salesforce's native APIs. Works well. You only consume calls to the Salesforce API whenever you need. But still, one of the caveats is that you're still using Salesforce APIs. So whenever you have multiple objects to create, to update, to query, you're going to make a lot of calls just to update one piece of customer information. Okay? So, but it still works. You're still doing less calls to the APIs because you're only doing it on demand, not every 1, 2 seconds, 5 seconds. It doesn't make sense. And if you want, you can actually bunch together all of these calls into one request, in the composite API request, and then you're using less resources on Salesforce side. So this is when we're calling Salesforce native APIs. The next variation of this, so this is an example of a Talend data integration job where we were doing all of this. It's an iteration where we have some data on the left, and then we're branching out because we have to check so many things in Salesforce before we can actually update or create records. Okay. Now, based on the same kind of mechanism, in our enterprise systems, we're generating messages with new customer information. We send it out to a queue that is dedicated to Salesforce, and now we have to consume the messages to bring them over to Salesforce. This mechanism here is our job that's reading from the queue, that's picking up the message, is turning around and connecting to one API, one single API in Salesforce, and passing the whole message to Salesforce. You know what? We don't want to process this message. We're going to leave it to you, Salesforce developer, to actually process this message for us. You can write Apex code instead of writing a data integration job. So This API here, after step 3, the only thing it does, it receives a message, turns around, it's going to write that message into a dedicated custom object in Salesforce. And at that moment, let's say we have a trigger on that object, what it's going to do, trigger an Apex code that's going to pass the JSON and read whatever it wants from the message and populate whatever object or objects it needs to. So we're pushing down to Salesforce and put the burden on the Salesforce developer to actually consume the messages. So this is very in line as well with our orientations. Okay? So what I'm going to do, this is a piece of code, Apex code, to actually consume the message. So in the red piece here, it's the definition of our message in our format. And in blue, it's deserialized. Here's the payload, deserialize it, follow this map. And then you get your whole JSON object within an object in Apex code. And from there on, you can consume whichever piece you want in the JSON. And you update everything in Salesforce. So the benefit of this is that you only do one call to any Salesforce APIs to process one message. And actually, if you bunch them all together, up to 25 together, you're making one call to update up to 25 messages. And when you're doing that, the only downside is you're creating latency in processing the messages. So you're just waiting to buffer up until you empty the buffer with one request to the API. It's a nice way to do it as well. It just depends where you have more resources and where you're more comfortable in developing. Okay? So this is something I want to demo. Okay, so here I have where is it? Here. So I have an ESB job that is scanning a ActiveMQ queue, and whenever I'm going to push a message into that queue, the ESB job is going to pick up the message, turn around, and call a connected app on Salesforce that is dedicated to receiving the message, turning around, saving it in an object, and processing it through an Apex code. Okay? So now I've started my route. I have my queues here, and I have a JSON message already prepared. So my JSON message here is a customer information. It's pretty much contact information, emails, phone numbers, addresses, information on the business, when it was incorporated, when it was established, and so on. The name of the company, the name of the owners, the name of a bunch of emergency contacts, and so on. Okay, so I've got a nice little JSON of about 300 lines. Here's my Salesforce instance. Just updating them, refreshing. So here I have accounts. I have a dedicated object for my JSON messages that are going to push into Salesforce. So it's empty. I have no accounts either. I'm going to go into my dedicated queue for Salesforce. I'm going to paste the JSON message, and I'm going to send it. So let me just this, so that we can see back here that this thing is processing. I'm sending the message. It's being picked up. It's already processed through. This is my JSON object. So I received the message. This is the payload that I sent through ActiveMQ. And when I refresh the accounts, this is the account that was created in Salesforce. Okay, so when I go into the account, so it was Pizzeria Belloy with a phone number, a global ID, MDM ID, industries, date of incorporation, establishment, and so on. Some business emails, personal email. So for example, if I go into my JSON message here, I've got a business email, I have a personal email. Let's say that I decide to delete the personal email. Okay, we're going to send it again. Sending it, refresh it here. Oh, sorry, going back. Second message came in, and here I had a business email and a personal email. I'm going to refresh the account, and ta-da, the personal email just disappeared. So it's a very nice way for us to integrate between the two systems, following our general enterprise architecture guidelines, which is push down to the consumer the burden to consume any messages they're interested in and integrate in that way with any enterprise system. Okay. So now, so now in a concluding note, you have people, you have a bunch of constraints that change over time as well. You get tools, you get a strategy, and now you have to decide how you want to implement. So the idea of this presentation was to give you some feedback of how we built things. We tried out different ways in integrating. We started with certain integrations, then we moved on to different integrations, playing with all of these different criteria at the same time and navigating our way through the different hurdles. Thank you. Thank you. So if you have any questions, I will be very happy to answer those.
Can you explain the concept of ActiveMQ? Because we use it all the time.
I'm sorry, I didn't get
ActiveMQ.
What's the concept of ActiveMQ? ActiveMQ is one instance of a messaging system. So if you go with IBM, you have MQ series. The idea of a messaging system is a guarantee of delivery. Whatever you put, it's just like your mailbox. Okay? You get the mailman, he comes, he drops mail into your mailbox. It's your responsibility whenever you are available to go and fetch the mail. It's exactly that concept. So the box is secure, the connection is supposed to be secure, you have the burden to go and fetch the mail. Why do we want to do that? It's because we want to do asynchronous integrations. Whenever you are capable of going and fetching the information, you'll go and get it. ActiveMQ, for example, the way we're implementing it, we have multiple instances. Each instance is deployed on a cluster of machines, and all of the messages that get onto the queue get persisted onto the file system. So imagine that you receive one message, it's going to be replicated across 3 servers. They're going to persist the message, and then whenever you come in and fetch the message, it's going to be deleted from all of the servers. What does this allow us to do? If the ActiveMQ, one of the machines goes down, the 2 other machines are still up and running. If the whole cluster of 3 goes down, your messages are persisted on disk. As soon as our DevOps reboot the cluster, all of the messages get repopulated in the queue in the order in which they arrived. So that means that your messages, once they reach ActiveMQ, you should never actually lose any messages. And whenever you, on the other side, you're consuming a message, so first in, first out, that's how we decide to implement the queues. You go in, you fetch the message. You have different mechanisms to do that. Either you have double commit, two-phase commits, where whenever you finish processing your message, saved it in your database, you commit it at the same time on the queue to take it out from the queue.
So it's a protocol?
It's based on the protocol.
Like
Yeah.
email or POP tree?
That is for emails.
I'm trying
But yeah, it's an implementation of a protocols. Yes, it's a JMS protocols. So it's a good way for us to ensure that delivery of the messages. And then, you know, if we are getting too many messages and our workers are not capable of depiling the queue fast enough, what we can do is like pop up more workers. Instead of having one guy depiling, we're going to get 10 guys depiling, and then we just scale down whenever we finish with the job. No problem.